we're going to continue with calculations, and before we can do that, we need to know a couple of definitions. So here the definitions that we're required to know are the molecular formula and empirical formula. Now Dr. Bourne is going to help us. Now Dr. Bourne, can you explain to me what the molecular formula is?
I can. In the molecular formula, it tells you exactly how many atoms of each element are in the compound. So here we've got C for carbon, so there are 2 atoms of carbon and 6 atoms of hydrogen.
Excellent. So I think I've got the idea because you explained that extremely well.
Thank you.
So we have 2 hydrogens, 2 oxygens.
Correct.
And we have 6 carbons, 12 hydrogens.
So far, so
No,
good.
so that's good. I think you've explained that really well. Now, this new word,
Empirical?
empirical,
Right.
what does that mean?
Well, in this context, the empirical formula tells you the exact ratio of the atoms of each element in the formula.
So it's like the simplest ratio?
The simplest ratio.
Perfect. So let me just try one and you can just tell me if I'm getting the idea of it.
Okay.
So here we have 2 carbons with 6 hydrogens.
Yes.
So the simplest ratio would be if I divide that by 2, then I would actually get 1 to 3. Is that correct?
Correct. So that 2 comes from there, and that 6 comes from there, 2 to 6. They both can be divided by 2. That's the biggest number they can be divided by. So that's 1 to 3.
So if I just put divide to make
Yes.
it clearer.
So what would the empirical formula be?
Right, I hope I get this one right. So C1H3.
Almost. Correct in principle, but in chemistry we never write the 1 in.
All right, so I need to remove that.
Yeah, we'll take that out. So CH3 is all you need there.
So the molecular formula is C2H6.
Yes.
The empirical formula is CH3.
Correct.
So I'm going to go into a slightly trickier one. This is hydrogen peroxide. I often use peroxide in my hair. Now,
Not
here-
noticeable.
just ignore that. So here we have a ratio of 2 to 2.
Yes.
Now that can be divided by 2.
Yes.
Again, I like this. And that gives you a ratio 1 to 1. And if I'm following your instructions correctly, it would be HO.
Excellent. Perfect. The last one.
The last one is hexane, and the ratio is 6 to 12. Now, I figure out that can be divided by 6. And that gives you a ratio of 1 to 2, which means your formula would be CH2.
Bingo. All correct.
All right, so that means the empirical formula for this, which is ethane, is CH3, hydrogen peroxide, HO, and hexane is CH2.
I think you're ready. Or in fact, perhaps the audience would like to try and do a trickier
Oh,
one
let's
themselves.
actually see. We have prepared an example. Now, you're going to try this example, and we're going to pause the blog even.
Pause.
Pause. Play.
So we hope you have written the answer down on a piece of paper, and then your answer should be CH2O. Let's hope you got that right. Let's hope so. Now, in this example, Miss McLaren, we went from the molecular formula to the empirical formula. But what if we were given the empirical formula and we had to work out the molecular formula?
That's a very, very important question, because the molecular formula is a whole number multiple of your empirical formula. I'm going to show you how. So, we have CH3.
Yes.
And if you can relate it to the molecular formula, you can see all you've done is multiplied the number of atoms by 2.
So going from molecular to empirical, you divide by a whole number, and if you multiply by exactly the same number, you can go from empirical to molecular.
Perfect. So let's just prove that point. So we have an empirical formula of HO. We can relate it to hydrogen peroxide H2O2, and again, you multiply it by a whole number. And let's prove that the final one that we did. So you have CH2, and you need to multiply that by a whole number to give you the C6H12.
Absolutely fantastic.
So now we understand what empirical formula and molecular formula is.
I think you're inspired.
Well, I hope the audience feel inspired as well.